Hello, students. In today's ATL online session, we will learn how to build a catapult. We'll see what catapult is, its working principle, but primarily we are going to focus on learning carpentry. So let's see what catapults are. We'll learn about their physics, how they work, their working principle. Basically, they used to propel the cannonballs or stones or arrows in the wars in earlier days. So these catapults are basically ballistic devices used to launch a projectile to a great distance, without use of any other gunpowder or propellants. So they basically release the stored potential energy to propel the payload, like as I said, cannonballs or arrows or, or stones. So they use springs, bows, twisted ropes, or elastic material in the mechanisms. Let's see what are different types of catapults were there in the world so far. So medieval time frame in the European countries, they used to have different types of catapults. So this one basically shows an arrow throwing catapult. They were holding this mechanism, and by the tension of the rope, they will release the arrow. Now the second one that we are going to see in this picture is basically a stone throwing ballista. You will see here in this picture. So there is a stone that is basically held by the rope, and they are going to release that kind of a bow, and it will be thrown. So this is how that mechanism will be basically used to launch that or project that arrow. Now these people have tightened that rope or the mechanism, and then will release. Seen that the arrow is released like that. So another one is torsion powered onager. So you can see that there is a rope at the bottom of this mechanism. So they will tighten that rope, and there is a sling at the end of that the rod. There is a spring, sorry, the sling holding that stone to be thrown. It's called as a onager. Another type is mostly it was used as a uh, catapult was a trebuchet. Now let's see how it basically works. It works on the principle of leverage and fulcrum. So you might have seen or might have heard learned in your physics how the lever mechanism works. So let's see how it works basically. So these are basically trebuchet used mostly in the European countries. They were basically in the walls, the behind the walls of castles and palaces to throw or project the rocks, cannonballs. Let's see how they work. So it works on the principle of a lever. So it will have a lever. Then there is a sling holding the rock, and it will work on the principle of leverage. So there is a fulcrum. Along with that, the lever is turned, and now the stone is thrown through that sling. So the stone will be thrown like this using that mechanism, and it will be hit onto the walls of the castles, the rocks. So how basically it used to turn. So how people will basically they will turn the lever using this fulcrum mechanism, and that stone will be thrown like that. So without people, how basically the trebuchet also used to rotate. So it worked on the counterweight mechanism. So there were also counterweight trebuchet. So you can see that the arrow. So it is a counterweight. So basically it will when there is no weight, the sling will be on the floor position like that, and it will be held by the pin. Now they will add more weight to that counterweight section. They will release the pin. So adding more weight on the other side, what will happen? The lever will be rotated along the fulcrum, and the stone will be projected like this. So interesting, is it right? So how does mass of object affect? So heavier the object, what will you think? The big rock, the heavy rock, and the small rock, which one will go further? Let's see. Oh, the small rock will go further because of the inertia of the object. The big rock will have more inertia. Now, this is Mangolin. So, we are going to build a catapult using this principle of Mangolin. So, let's see more about this catapult. So, it will have bucket, payload, arm, and cantilever spring. We are also going to create a frame for this. So, we'll build this catapult today. Let's see basically what modern day catapults are. They are used in the aircrafts. So these are big aircraft carriers. the warship carriers. How catapults are used to basically lift the aircrafts on the ships. So, as you can see in this picture, there are different types of warships that are, many countries used across the globe. So they are basically used to land the fighter air jets of their air force, and they are also used when most of the countries do not have their air bases, the dedicated air bases to land or to take off their fighter jets across, their air force or navy operations. As you can see that this airship carrier is basically have different parts of the ship where these fighter jets are launched. There are different lengths, so ranging from 300 to 337 meters as compared to 2000 meters for the regular airports. Now let's see how basically these aircraft catapults work, which carry approximately 90,000 metric ton of load. And that too, they take off the flights within the distance of 300 meters in a few seconds. So basically, the aircraft ship has two catapults, one at the bow, that the front side, and the two on the port side. On the top, you can see that there are two catapults. So the two airways. So now the catapults on the port side are at angle so that the pilot can land the aircraft without any difficulty. So this is how the aircraft catapult works. So there is a chamber where the high pressure steam is stored in the accumulator. So the steam is generated by the nuclear reactor, and when the nuclear reactor will generate the steam, it will be stored and it will pass to the flow control wall until the accumulator is filled. So you can see that in that control pod where the operator basically who will release the steam, who will release the catapult, will basically will look at the pilot, and when it is ready, it will release that air pressure. It is approximately 3.2 megapascal. So at such a high pressure, it is held. So when the aircraft comes, it will be held into that catapult. So there will be a jet blast deflector at the back of the aircraft. So there are two fulcrums basically which are held by at the shuttle, and then the shuttle is basically attached to the piston, that orange piston that you can see in the picture. So this shuttle is connected to the piston. So this piston is basically moving forward and backward using the steam pressure. As you can see on this picture, so there are two cylinders and the two pistons. So in the bottom picture, we can see only one, but there are two pistons. So this shuttle that you can see on the top is passed through the track, and it will be held. It will be holding the aircraft. So as and there is a mechanism called as grab. It will hold the mechanism for aircraft, and there is one hydraulic cylinder at the bottom of this mechanism. So what it will basically do is the tensioner will push the grab, and it will move the piston forward, and it will basically connect. The grab will be attached to the mechanism. So the red bar that you can see is basically helping the carrier not to move behind. So there is a launch valve. So when the aircraft is to be launched, the catapult is to be launched, this valve will be opened. The steam will be pushing the cylinder forward. So at 20 metric ton, so the aircraft will go to 265 kilometers per hour within 2 seconds, and the aircraft will move out of that, and it will create 5G of speed. So into such kind of rides, so 4G speed, that is 4 times or 5 times gravitational speed. So 750 kilonewton of load will be applied at such a high pressure, and the aircraft will come at the end, it will be released, and the flight will take off. Now this grab will be coming at the end. So as the flight is released, the steam is again be released. The grab will come at the end of the mechanism, and it will take the piston back to its original position. So this is how basically, and the next carrier, the next aircraft will come and be ready. So let's build our own catapult using carpentry skills now. These are the tools required: drill bits, wooden material, wooden planks and boards, a hacksaw, hot glue gun. We will also need three pencils, measuring tape, marker. We will need bench vise, C clamp, and definitely safety equipments. We will also need the sandpaper, brush, and wood polish. We are going to use wood polish to polish the wood. The first tool that we will need is hacksaw. So hacksaw is basically you can connect the blade using two pins. There is one screw at the end. The hacksaw blades are always to be aligned forward so that it will help in cutting. If you align the blades, the tooth backward, it will not cut the wood. The more number of tooth per inch, it will be used for thinner material. So you also will get that specification on the hacksaw blade, that how many number of teeth are there on the blade. More number of teeth, it will be used for thinner material, and that's how it will basically work. Now this is a mini hacksaw. You can see that the gap between the blade and the top frame is more. So they are used to cut smaller and intricate jobs, unlike the big hacksaw. So these blades are also removable and replaceable as they are worn out. So make sure that now the next tool is the drill, the corded power drill that we are going to use. All of you have the drill machine in your labs. Now let's see basically how to use the drill bit, the drill machine and the drill bit. So this is a Bosch drill machine set that you all have in your labs. Hammer is used to fit screws. Wrench is basically used to provide the grip to tighten the nuts and bolts. Plier is used basically to lock and adjust the screws and nuts again. So this is basically a level to adjust. It will basically detect the surface level by adjusting the fluid drop. These drill bits are used for metal surfaces, the black ones. These middle ones are used for wall surfaces, concrete. And these drill bits with the sharp end at the tip, they are used for wooden surfaces. We are going to use these drill bits for our carpentry operation. Now let's see how to use the drill machine. It has two modes, wooden at this end and wall at the another end. So it works on three directions: clockwise, that is forward, in the lock condition, and anti-clockwise for the reverse direction of the drill machine. Now let's see how to tighten the drill bit. Select the desired drill bit size, tighten it by hand initially, and then using this key, tighten the drill bit. Now another tool that we will need is the bench vise. So it is very much important that you use the vise for carpentry operations. Do not hold the job in the hand and then use the drill. So they are basically used to hold the job, and these type of vices are removable. This is a different bench vise. It can also align the job at a different angle. So this is a little different bench vise, but primarily used for holding the job. These are C clamps. They are again used to hold the jobs on the table or any other surfaces. So you will need to clamp the job appropriately. This is ball peen hammer that we are going to need to hammer the nails, and the spherical surface is going to basically use. This is a claw hammer. One end is to hammer the nails, and another side is to remove the nails. So if unnecessarily, and this is a file set. So we are going to use the file set. You all have different files in your lab. So we are going to use the files to smoothen the wood surfaces. Next thing that we are going to need is zip tie to tighten some of the parts. Now let's start with marking the plates. So base plate, this is a catapult that we are going to use. This is the dimension. So 20 millimeters from either of the sides and 50 millimeters. So total is the 90 millimeter. You can see in the figure. Let's mark 40 millimeters from one edge, and now let's draw the lines as per the marking. You can pause and see that base plate drawing. Now this is at a 200 millimeter from the edge. We have drawn so base is basically 200 millimeter in length in total. So now this is side plate. So we are using 20 millimeter thick plywood. So 40 millimeters in length and 150 millimeters 40 millimeters in width and 150 millimeters 155 millimeters in length. So mark 155 millimeters, and there are two side plates. So another side plate 155 millimeters. So two side plates we have marked. So 40 millimeter in width and 155 millimeters in length, and the base plate. So 90 millimeters wide and 200 millimeters in length. So this is launcher plate, 8 millimeter thick, 40 millimeter wide, and now mark at 40 millimeter wide. Draw a line. Basically, we are going to cut that to 40 millimeter width. Now we are going to mark it 305 millimeters as a total length that we need. Mark 300 millimeters first, then another 5 millimeters. So the total length of this launcher plate is 305 millimeters. So we'll mark that. Now all the plates are ready after marking. Now it's time to basically start cutting. So first start cutting the base plate. So use the appropriate clamps, saws and safety equipments. Now we are going to use the adjustable bench vise. We are going to use two of them because some of the wooden boards are longer in length like this base plate. So it is better to clamp this base plate using two bench vise so it gets a proper support like this. So tighten the job properly. Use hand gloves. Keep the base plate upright, and start using the hacksaw. You can use this type of hacksaw as well, or the other type of hacksaw with the frame that I earlier shared. So start cutting across one length. We are not going to show the entire cutting process here. This side is basically cut. Now cut the another edges that we have marked. They're 20 millimeter deep. Now remove the job and basically attach it vertically. Tighten the clamps again and cut along these edges. So they are 40 millimeter in depth. Now the other side of that, same thing, 40 millimeters. Now let's cut the along that entire line, right from top to until 200 mm, and remaining we can cut this at the edge, and thereby we are ready with the base plate. Now let's cut the side plates. So use proper clamps again and saws and safety equipments. Clamp the side plates using the C clamp. Cut along the marked edges. Use this type of saw or hacksaw with frame. Cutting it at 150 millimeters. One plate is ready. Now cut the second plate. Make sure that your cutting edge is very close to the clamp so that you don't get too much of overhang. It is easy and safe that way. Now cut along that edge as well, and we are ready with cutting at the length. Now to cut it exactly at 40 millimeter width, repeat the same procedure for second plate, and we are ready with a base plate and two side plates like this. Now cut the launch plate. Again, use proper tools, clamps and saws and safety equipments. Now the launch plate, again clamp the cutting edge very close to the table. Now cutting along the vertical length, turn the job, clamp it vertically into the vise. And since it has more overhang, cut it easily and slowly. Check all the parts together when they are cut, whether they are fitting appropriately, they have enough gap between the two plates. This is how it will look like, when all the parts are cut. Now we are going to use pencils as a fulcrum mechanism. So they are 7.5 millimeters in diameter. So we are going to use a drill machine to cut, to make drills of 7.5 millimeters in the side plate. So there are two holes along the side plate. So we are going to clamp two side plates together. Mark at 25 millimeters from the top edge, then draw a line parallel to the edge and mark the midpoint of that length or that edge. So, which is 20 millimeters. So, mark the middle point. Same thing, draw another line at 10 millimeters, 10 centimeters on the top and draw its center point. So, now we are ready with making drills. So, use the wood drill bit and make the through drill through all that two base plates, two side plates. Now turn the plates other way and drill the second hole or make the second hole. Make sure that you are using gloves and goggles. We are ready with side plates, base plate, launch plate, and three pencils. So now it's time to use sandpaper to smoothen the edges and surfaces. It is very important before we color or paint the wood. We will need sandpaper and we are also going to use polish. So use gloves because while also sanding the job or using the sandpaper, it is going to remove the smaller wood particles and you might not want to get injured because of these small particles. Now polish or smoothen the jobs along all the edges using sandpaper. There are different types of sandpapers. Use the medium grade sandpaper and just move the sandpaper very with medium pressure. Do not apply too much of pressure and do not also use too light a pressure. Move the sandpaper along the surface as well because we are going to paint all the edges surface as well. Now polishing the rather using the sandpaper on the launch plate. Remove all the burrs, all the sharp edges. Now polishing the main surface of the launch plate as well. Now we will use the files to smooth edges and surfaces. We have used the sandpaper. Now it's time to use files. So all these files that you are available, that are available in your labs. Now clamp the job for filing. It is very much important that you clamp the job. Use the file as shown in the video. Put your left hand on the top of the file. Apply very medium pressure, and so that you are going to smoothen the sharp edges of the wood. We don't want sharp edges so that it becomes easy to handle. So we will smoothen all the edges of all the plates. Do not apply too much of pressure, otherwise, since we are using plywood, it is easy to file and cut. Now let's use ball pen hammer and nails for joining the base plate to the or other side plates to the base plate. So clamp the base plate on the vise like this. We are ready with base plate, and now take one side plate. So make sure that the top hole is aligned on the top, and then use the nail, use the gloves, and carefully nail the plate like this. Do not hit too hard so that the plywood will break. The plywood may get cracked if you hit the hammer too hard. Now second nail, again take care while applying the hammer on the nails. So this is how we are going to use the hammer and the nails. Now before we tighten the second side plate with nails, just insert one pencil through those two holes so that the other side plate now which is on the top is held exactly, making sure that there is an alignment between the holes because we are going to insert those pencils for our catapult. So these holes need to be aligned. So after aligning using the pencil only, you try to you basically use nails and hammer. Now let's use hot glue gun for dowel pins. We are also going to keep the blue pencil, this green pencil while nailing. Now apply the hot glue all around the top dowel pin. So we are going to use pencils as dowel pins since we are not going to buy any other round wooden parts. So apply a hot glue gun all around. Now at 10 millimeter, 10 centimeter length on the launch plate, apply the hot glue and put another dowel pin, put another pencil as a dowel pin, apply hot glue gun all across, again length. We are also going to use zip tie to basically tighten this all these pencils on the launch plate. So apply hot glue on another side of the launch plate. Yeah, so this is how your mechanism is ready. Take one spoon. If you don't have spoon, use any spherical surface material. This spoon is going to be used as a launcher. So now make two drills on the launch plate and use zip tie to tighten this pencil. Put zip tie outside of the plate also. Now we are going to assemble another plate of that length, so that yeah, so we are cutting the extra edges, extra length of the pencils we don't need, and we have also put zip ties. Yeah, we are going to put zip ties so that when we are going to use rubber band for using our catapult, those rubber bands will not fall off those pencils. So zip ties will make sure that the rubber band will not fall off from those dowel pins or pencils. Cut those extra length of the zip ties using the cutter. Now we are going to use the wood polish for coloring. You can use any other paint. Make sure that you use brush. Do not use cloth, or do not just paint the wood surfaces using hand or cloth. It is easy and safer using the brush. So apply the wood polish all across the surfaces. It is optional basically to paint, but if you have paint or wood polish, it is basically easy and your catapult will look better after coloring. So our catapult is ready. Let's launch the ball. The ball is projected and it is thrown at a farther distance. So we try to make different attempts and made our catapult work. We can use a rubber band or hair band. If you have any questions, I'm available on the channel to answer your questions. Post them on the channel. You are also going to refer to this video on the channel later as well, and you can record your questions and post them to me on the channel, as well as on the ask your ATL in charge to post their questions. So thank you very much for watching this video. You learned the mechanics, the mechanism behind the catapult. You learned how their modern day catapults are worked in their aircraft. You also learned how to use carpentry tools to build our own catapult using carpentry. How to use hacksaw, how to use the bench vise, how to use the sandpaper carefully, how to use the files, and why it is important to use the bench vise. Thank you very much again, and see you in the next session. Bye bye.